Hi, welcome back. This is Shoptalk number 8, I think, and we have a lot going on in the shop right now. The biggest change will be that I'm in the process of selling my CNC milling machine. The CNC milling machine, the rotary forked axis, and the control PC over here, also with the tooling up here, will go away. I will sell them off and I will go back to manual. I'm going to buy a manual milling machine, maybe even a Chinese one, and I want a machine with more travel in the X and Y axis, and also I want a geared machine. I want a gear head spindle. I want torque on the lower end of the speed spectrum and quick speed change without changing belts or stuff like that. As far as I'm concerned, it's going to be a one of the RF45 clones that are out there. I will head down for a friend down in his shop and do a few test cuts on his RF45 milling machine and see how I like it. If it's sturdy enough, if it can take the cuts I want to do. Okay, we're over at the bench, and very many of you have watched my video on my Chinese 9x20 lathe, and I mentioned that I'm using the indicator holder on the right side of my bed slide, and that way I'm losing a lot of travel because the bed slide can only go that far, and that way I'm losing about 10 to 15 millimeter of travel. A few people suggested that I take my indicator, pull it out, and set it like that. And that's a great idea. I was never thinking of doing that, and the only thing I have to do is to open up this bore, because the rear stem of the indicator is bigger. It's 10 millimeters compared to the 8 millimeter stem in front, and as the milling machine is up for selling, I can't use it anymore. I'm not going to use a machine that's for sale. I will do this on the lathe. Okay, we're over at the lathe, and I chucked up a piece of 8mm round stock in the chuck, and there we can slide over the bed stop, or the indicator holder. Going to hold it in place with the clamping screw, so it doesn't wiggle around while we're setting it up. And now we're just going to support it with 2 screw jacks, and then we'll clamp it down. Okay, that way the indicator holder is supported with the 2 screw jacks, and now we can clamp it down. Okay, I clamped it down. I have one long bolt through the rear mounting hole and one strap clamp here in front. It's a bit half-assed, but we're just drilling and reaming. I put a brass shim into the slit of the bore so I don't pinch it when I'm clamping it down. And now I can move it out. We open this recharger, pull this out, remove our alignment bar and go to work. Okay, I hope this doesn't go wrong horrible. So I set up a 9.5mm drill bit in the chuck and we go to open up the hole. I don't want to push too hard as the setup is a bit ugh. Okay, that's the drilling. Now we change over to a 10mm reamer. The bore is interrupted by the slit, but I'm using a reamer with a slight spiral, and that works. You can't use a straight fluted reamer with an interrupted cut. That's not going to work out fine. It will grab, but with the fluted one you can get away with it. Yeah, this is aluminum. We can go a bit faster. There we go. Okay, let's do a test fit. And there we go. Okay, and that's how the indicator, the now modified indicator holder, looks on the lathe. I have my full 50mm of travel. I have a hard stop down here so I don't crash the indicator when I'm cranking to the extreme right end. There's still about 0.2 of a millimeter travel left when I bump into the stop. And also I made a protective cover for the outer end of the indicator. As there is a slot with a pin that stops the measuring stem from rotating, and also the measuring stem is extending out. Ooh. Yeah, this is not the best indicator anymore, but sometimes this works. And I made this protective cover to protect the end from bumping into it and from dirt, so it doesn't get any worse than that. So that's the modified indicator holder. Thank you for all you viewers that commented on this indicator holder and gave me the idea to mount the indicator with the stem held in that place. For some reason I didn't come up with that idea by myself, so thank you. Okay, we're again over at the lathe, and sometimes you have the problem that you want to hold a very thin part, very small thin part on a magnetic chuck, no matter if it's the lathe, the cylindrical grinder, or as obviously the surface grinder. Very small parts are very badly held by the magnetic chuck, as I can show you with this fender washer here. This holds very bad. But you still have to machine the part, and what you can do is to block in the piece. And for thin pieces like this washer, you can use shim stock or feeler gauges. Arrange 3 pieces in a way that it holds the part like a 3-jaw chuck, and you're good to go. That way you're able to take a very light cut on your piece that otherwise would fly away from the magnetic chuck. And I can show it to you. I have to surface off a few hundredths of a millimeter of this piece, and let's see. And there we go, we were able to take a nice facing cut on this washer. Now I can turn it around and do the other side. Once you have machined one side, it holds better to the magnetic chuck, as the surface is absolutely flat. More contact area to the magnetic chuck means better holding power. So that's my little tip for magnetic chucks. It's nothing new. I think everybody who runs a surface grinder with a magnetic chuck, and that should be almost every surface grinder, knows this trick. But just to be curious, I wanted to show it here, especially on the lathe where it's not that common. Okay, let's flip the part around and do the other side. Remove our blocking pieces. Wipe off the magnet. Clean all the parts. You don't want any dirt between your piece and the magnetic chuck. This will also reduce the holding power. There is always some remaining magnetism in the chuck, even if it's turned off, and that we can use to align our piece. And as this is not a precision thing, I just aligning it by eye. I only want to take a facing cut, not turning the actual outer diameter. Now we can block it in. The first piece goes, and try to use the blocking pieces across the magnetic poles of the chuck, and the holding power is way higher. Next piece goes diagonally on there, catching as many of the poles of the magnet here. And the third piece, I ground a little notch in it, so I can drop it on here, also diagonally to the magnetic poles. Okay, that's good enough. Switch on the magnet. Now it's firmly held in place. Okay, that's it, and that's how you hold thin parts on the magnetic chuck. And as I mentioned earlier, my CNC milling machine is going to be sold, and this is sometime in the future, and it's gone. No CNC milling machine anymore. We're going back to manual machining. Okay, I know that some people don't like the I got a new tool stuff and all the videos out there, but I think this is, and normally I don't do that very much, but in that case it might be interesting. I got this on a trade. I traded this for another item, and this is a Swiss-made Isoma measuring microscope. So it's in first order, it's a microscope with relative low magnification compared to a laboratory microscope, but it has a cross slide down here. It has a table that can be moved in a very precise manner in 2 axes with this micrometer drums. And the way this works, the table runs on ball bearing guideways and is preloaded, with a spring preloaded, so there is no backlash in the screws. In fact, I can show you the preloading. When I pull the table, I can pull it against the spring, and the spring will pull it back against the screw. So, you see? So this is always without any backlash. There is a glass table here. It can be rotated. So you place the piece you want to view on here, and then you move your 2 axes until you have the piece in your view. This works like a normal microscope. You look in here, you adjust for focus here. By the way, this up here there is a rack and pinion, and the dovetail ways up here are scraped. They look like they are very fine scraped, and of course it has an adjustable gib. So you place your piece, and when you look through the eyepiece you have a crosshair, so you can use the table, line the crosshair up with one feature of the part you're viewing, zero your dials, and make measurements by moving the piece. And the micrometer drums read to 1/100th of a millimeter, but they have a vernier and they can be read to 1/1000th of a millimeter. And I tried it on a 3mm gauge pin that's 3mm nominal, and this gets incredibly close. It's super precise. What you can also do is you can loosen up the screw here, and then you can rotate your eyepiece with the crosshair in it. Yeah, oh, wrong screw. That screw is for the 0, and this screw up here is for the eyepiece itself. You get a 360-degree scale here, and that way you can measure angles. For example, if you want to measure the included angle on a single lip cutter, you can use this device for that. I have a picture where you see this. You see the tip of the single lip cutter, and I have lined up the cutter with the axis of the cross slide, and then I rotated the crosshair until the line matched the angled side of the cutter, and that way I could measure the angle. And as you can see on the picture, it's slightly less than 50 degrees, so it's a 30-degree included angle cutter. It will cut a 30-degree groove. So this is a very precise and very super heavy duty made. It's all cast iron and it's pretty heavy. I think it's about 20 to 25 kilograms. And it has lighting down here. Down here you can see the green light, and that's also adjustable in brightness. That's when you want to view the profile of a piece. You can also use this. This is an ancient ring light, like you put on a camera for macro photography. And what this plugs in on the back of the microscope. And you have a ring light. You can put it onto the lens down here. And now you can observe the surface of workpieces. You can measure the width of engravings, or you can... here I have a picture of a scale, a shop scale, a steel scale. The big lines, there you can see two big lines, and those are apart 1 millimeter. And yeah, that's what this ring light is used for, to observe the surface of workpieces. If you remove it, you get just the shadow projection, the real lit picture of your workpiece. Both have their uses, but you have to decide from case to case what to use. So there you have it, Toolmakers microscope. This is a pretty nice, super nice unit, and I already love it. I only need to clean it a bit. Okay, this is the setup I'm using for photographing through the microscope. I have my trusty old Canon EOS 350 here, with the kit 18 to 50 millimeter zoom lens and a macro ring, so I can get closer to the ocular of the microscope. And the rack over there is so any light from the outside doesn't obscure the photo. I got really weird halos when I didn't use some darkening over there. And the camera, of course, is on a stand, and the camera is on timer, so I don't get shaky pictures. And it seems that you can remove the eyepiece here and screw on an adapter, so I will investigate on that, and maybe we're going to make an adapter from this eyepiece to the camera lens, so I don't have to fiddle around with the stand to get the view through the viewfinder into the microscope right. And down here you see our victim. We have a 40 degree, or yeah, I think it's 40 degree single lip cutter. I taped it down so it doesn't roll around on the table of the microscope. And right now I'm using the additional ring light, so I get a picture of a real picture of the part. And I have still picture right here. You can see the surface of the piece in that picture. And if I take out the plug for the ring light, we get a shadow image of the single lip cutter, and that's to check the profile of it. Now you could measure the width of the tip and the angle and so on and so on. With the shadow image, this is almost like a very small profile projector, and a profile projector is something I wanted for a real long time, but those things are really big and take up a lot of space. And this microscope is the next best thing to a profile projector. Okay, this was a very short shop talk episode, but on the end I wanted to give you a short teaser on some maybe upcoming projects. Right here, 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 and maybe here. So, thank you for watching. See you next time.